Hello, my name is Bo Sowers. I am Lab Section 02, and today I'm going to be giving my oral presentation on our second lab experiment. So now we're going to talk about our copper reaction scheme. So first thing is we started with CuS, which is a solid, and we added NHO3. So when we added NHO3, we got CuNO3 and 2. And it's aqueous because when we added it, it turned bright blue and it was a water-soluble salt at the bottom. Also coming off that NHO3, when we got it, right off the start, we got NO2, which is a gas, and it was a brownish red gas that was released into the air. So after that, we added NaO3, getting CuOH2, and that is a solid. And we got that because after we did that, it was a black water insoluble salt, and it was kind of squishy at the bottom. So that's how we told us that. Then after that, we also got NaNO3, which is aqueous because we got a kind of white salt that dissolved in the water and gave us like a kind of yellowish solution. So then after that, we heated the process, and we got CuO, which was a solid because we got that black kind of water salt again at the bottom. When we got that, we got H2O, which is a liquid, because we got a just bright colorless liquid out of it. So after that, we added H2SO4, giving us CuSO4, which was aqueous because we got, again, that bright blue thing that we kept getting at the beginning, and it was water, and there was a water-soluble salt at the bottom of the solution. We also got off of that H2O again, which was a liquid. So after that, we add Zn into it. We ended up getting H2, which is a gas. We got a colorless gas coming off of it. And then we got ZnSO4, which is aqueous because it was a white salt that dissolved into the water, and we got it was like this little salt solution that was kind of stuck to the side. So after that, completing it, we got ZnSO4 again, also being that aqueous solution because of that white soluble solution we got from it. So now, following our chart, we have to do the calculation of the percent yield of copper. So to do that, we have to do the recovered mass over the initial mass of copper times 100%. So by doing that, we took our recovered mass, which was 0.582, and divided it by our initial mass, which was 0.512. We times it by 100%, or multiplied it by 100%, and we came out with 114%. So after the equation, we're now going to talk about experimental error, which is an error that can occur in any experiment. So we're going to talk about an experimental error less than 100%. Could have happened when we decanted, because when I decanted, a lot of our solution got into the other beaker because it was very hard to stop it from staying in our first beaker. Then for our experimental error being greater, it could have been when we added all these chemicals into one beaker time after time. There's a chance that not all of it may have gotten out, either through heat or decanting or any of the things that we did, making it above 100%, which you see as we did. We got above 100%, getting 114%. For my reference, I used the Chemistry 110 Foundations of Chemistry Laboratory Manual, and as you see, we added all the professors' names and where it's from, the University of Mount Union, Alliance, Ohio, 2019. I used pages 7 through 13.